All right, let's get into something that sounds like pure science fiction. We're going to break down how scientists taught an AI to forecast the weather, but not on Earth. Nope, we're talking about the weather on the surface of our very own sun. Just look at this. That's a solar flare. It's basically a gigantic storm of energy, and it's powerful enough to mess with our entire planet. We're talking about storms of radiation that shoot across space and can cause some major problems right here at home. So that leads to the big question, right? What if we could actually see it coming? I mean, if we had a heads up that one of these things was headed our way, we could get ready for it. But how on earth do you predict what a star is going to do next? You know, from here, 93 million miles away, the sun looks pretty peaceful. But up close, it's got this incredibly violent, totally unpredictable side. And all that constant churning, the flares, the eruptions, that's what scientists call space weather. And trust me, it doesn't just stay near the sun. So why should you care about any of this? Well, a big space weather event is way more than just a pretty light show. It can literally fry power grids, causing massive blackouts. It can knock out the GPS you use every single day. It threatens the satellites that give us internet and TV. And it's a huge danger for astronauts. The bottom line is our entire modern world, everything that runs on tech, is way more vulnerable to the sun's mood swings than you might think.
Okay, so people have been trying to use AI to predict this stuff for a while. But the old way of doing things, well, it just wasn't cutting it. See, you'd train an AI to do one specific thing, like spot a sunspot, and that's all it could do. Plus, it needed a ton of examples of these big solar storms to learn from. But these storms are pretty rare. But the biggest problem? These AIs were missing the forest for the trees. They just couldn't see the big picture of how the whole sun works together.
This is a perfect analogy for it. The old models were like a specialist doctor who only knows about, say, elbows. But they have no idea about the heart, the lungs, or the brain. You can't figure out a person's overall health by just looking at their elbow, right? It's the same with the sun. To predict what it's going to do, you need an AI that can see the whole patient. And this is where things get really interesting. This is where the game changer comes in. It's called a foundation model. So instead of being that narrow specialist, a foundation model is totally different. You train it on a huge amount of general data. The whole point isn't to teach it one little job, but to let it figure out the basic rules of the entire system all by itself. Okay, here's the best way to wrap your head around this. The old AIs were like someone memorizing a few phrases from a tourist phrasebook. You know, where is the bathroom? A foundation model? That's like an AI that moves to another country and learns the entire grammar of the language. It's not just repeating things it's heard, it actually understands how the language is built from the ground up. So when you apply that idea to the sun, whoa, the difference is huge. Instead of just teaching an AI to recognize what a flare looks like, this new kind of AI can start to understand the deep-down physics of what causes the flare. It's basically learning the grammar of the sun. So how did they actually do it? How did they teach an AI the sun's grammar? Well, that brings us to the hero of our story. Meet Surya. It's named after the Hindu deity of the sun, and it is the very first foundation model ever built just for heliophysics, which is, the science of studying the sun. Now, to learn this grammar, Surya couldn't just look at regular pictures. Oh no. The researchers fed it data from 13 different eyes all at once. It was basically watching the sun in all these different kinds of light, like ultraviolet, while also seeing its magnetic fields. It got the whole 360-degree, multi-layered view. And we're not talking about a quick glance here. The data came from a NASA satellite that has been staring at the sun without blinking since 2010. That is more than a decade of non-stop observation. It means Surya has watched the sun go through its entire 11-year cycle, from calm to chaotic and all the way back again. And the amount of data here it's just staggering. In total, they fed Surya 257 terabytes of data. To give you some perspective, that's more information than you'd find in the entire printed collection of the Library of Congress. It is a truly astronomical amount of information. So, how do you learn from all that data? Well, the actual task they gave the AI was pretty simple, really. They'd show it a picture of the sun. Then they'd show it another picture from 1 hour later. And then they'd ask it, okay, based on these two, what's the sun going to look like in the next hour? And by making it do this over and over and over, millions of times, Surya started to pick up on the deep, hidden patterns of how the sun changes over time. Okay, so that's the setup. You've got this massive AI, you feed it a mountain of data, and it supposedly learns the sun's secret language. But does it actually work? After all that, can it really predict a solar flare? Let's find out. Here's the test. The researchers gave Surya these two images. They were taken 1 hour apart, right before a big solar flare was known to have happened. That's it. That's all the AI gets to see. And here's the result. On the left, that's what Surya predicted the sun would look like an hour later. And on the right, that's what actually happened. I mean, look at that. It's almost perfect. Surya didn't just guess that a flare would happen. It nailed the location, the shape, the size, everything. It's stunning.
Okay, but maybe that was just a fluke, right? A lucky guess. So let's throw something even harder at it. This is from a massive, famous solar storm back in 2015 called the St. Patrick's Day event. This was a monster, a real challenge for any prediction model.
And look at that. Once again, it's just incredible. On the left, Surya's prediction. On the right, the real deal. This isn't just a blurry guess. The AI actually captured the complex structure of this huge eruption. This is the proof. It's not just memorizing photos, it's actually understanding the physics. And this is so much bigger than just a cool party trick for predicting flares. The scientists behind this call Surya a scalable backbone. What that means is it's a foundational tool, a starting point that other scientists can now use to build all sorts of new applications for research and for practical real-world forecasting. Because once you have an AI that understands the sun's grammar, you can fine-tune it to do all kinds of other jobs. You could use it to predict the solar wind that constantly bombards us, or to automatically flag dangerous regions on the sun's surface. You could even use it to build better models of the sun's magnetic field. Seriously, this is a huge leap forward in understanding not just our star, but stars everywhere. And all of this leaves you with a really mind-bending thought. For all of human history, we've just looked up at the sun in awe. Now, we've built an AI that can guess its next move. So if we can do that, if we can forecast the weather on a star, what else is out there? What other huge cosmic mysteries are we just about to unlock?